I'm going to continue on to lesson 18 with more problems on area and circumference. Before we begin, please make sure you have the following material. Pencil, which you should have already had, being that we already did a do now, a notebook or a piece of paper, and a calculator. Now, if you do not have an actual calculator, the cool thing about our little smartphones that we have here is we have calculators on our phones. So if you have an iPhone, please feel free to use the calculator on your iPhone. If you have an Android, I feel sorry for you. Nah, I'm just joking. Your Android should also have a calculator in it as well. I'm not too sure who still uses Androids, but that's beyond the point. Let's keep going. What is the main focus of this lesson for today? Students will examine the meaning of quarter circle and semicircle. Students will also be able to solve area and perimeter problems for regions made out of rectangles, quarter circles, semicircles, and circles, including solving for unknown lengths when the area or perimeter is given. Now, one more thing before I continue. As I read, I will have my cursor or my pointer moving around with me. Here it is, this little fireball thing that I like, cool little fireball thing here. Now, as I read, you should be following along. Whenever I write something or explain something on the board, you also should be copying it down, all right? Just wanted to throw that in there. All right, just a quick review. I know Miss Kate went over this with you guys earlier this week. We will go over it again, all right? Circumference. Circumference is, now if we were in class, I would ask the question because I know Miss Cates went over it and everybody would raise their hand. Circumference is the distance around the circle. Take a look at this diagram right here where you see C, and it shows you that circumference is in fact the distance around the outside of a circle. The distance around the outside of a circle is the circumference. Oops, sorry, let's go back. Okay, now radius. The radius, the distance from the center of a circle to the edge of a circle. So once we come back to this diagram, from the center to the edge. And the radius is half of the diameter, which we're going to talk about next. The diameter is the distance from one point on a circle through the center to another point on the circle. And the diameter is twice the radius, okay? Now, as far as the diameter goes, if you take a look at this, diagram right here, you will notice that this line right here is from one point of the circle going through the center to another point. All right, just a quick review. If you do not have this written down, if you did not remember this, please, please, please pause this video and write this down again. Let's keep going. Grade 7 math reference sheet. Now, this should look familiar to you. If it doesn't, I'm just going to end up pulling out the little bit of hair that I have left. But for the most part, everybody should have seen this at some point. When you're taking your state exams along with your interim exams, this is attached to all your test booklets. And it is a reference sheet that includes all the formulas that you should need or all the conversions that you will need for that specific test, all right? Now, we just put this in here so you guys could see it, remember it. Whenever you see this, always remember this is where your formulas will be. Now, we're going to be going over a few different formulas. Miss Kate's touched up on some of them already this week. I am going to touch up on them again. Now, for the opening exercise, we have to draw a circle with a diameter of 12 centimeters and a square with a side length of 12 centimeters on grid paper. Determine the area of the square and circle. We're going to do this together. Let's keep going. Now, Here is the square, and here is the circle. The square, the sides are, each side, I should say, for the square is 12 centimeters long. And so when I say sides, I mean this side is 12, this side is 12, this side is 12, and the bottom is 12. Okay, now for the circle, we have a circle with 12 centimeters in diameter, which means if we count all these boxes going across, if we cut it directly in the middle, going across, it will be 12 boxes, which is also 12 centimeters. Okay. Now, we're going to do two things here. The first thing we're going to do is we're going to find the area. We're going to find the area of the square. Second, we're going to do the area of the circle. We are going to do so using these formulas. I already put the formulas in for you. So using A equals S squared, which S stands for side. And for the circle, you're going to use A stands for area, of course. Area equals pi times R squared. That should have been squared. It's a big 2, but that was a typo. So go ahead, pause this video, and you have about 5 minutes to solve. And then when you're done, come back and we'll continue. All right. Now, you should have done your part and solved it. Now I am going to do my part, and I am going to solve it, and you are going to check your answers. Any mistakes that you may have made, you're going to correct your mistakes. And once again, if you didn't do anything, if you didn't know how, please pay attention to the next clip so that I can explain it to you. Here we go. Okay, so we have a square that I drew. It's not to scale, but it's the best I could. And we have a circle. This is definitely not to scale, but I tried. Now, this side is 12, this side is 12, this side is 12, and this side is 12, because it's a square. So all of our sides are equal, and they equal to 12 centimeters. This is diameter of 12. Now, if we're solving for area, we're looking for the area. So we did 12 squared, and we ended up getting, hold on, what's going on here? This can move, exit. Oh my God, I messed up. All right, here we go. Now, we have a square here, and we also have a circle. Now, our square, we have a S squared. Area equals S squared. S stands for side. So our side right here is 12. 12 squared would give us 144 centimeters squared. All right. And then on this side, we have a circle. Our formula for area of a circle is pi r squared. I repeat, pi r squared. Then we're going to go ahead and substitute. A equals pi times 6. Where we got 6 from, you're probably wondering, where did we get 6 from? Okay. Now, remember, if 12 is our diameter, then our radius is half of 12, which is why I put 6 where r is supposed to be. Then we have 6 squared. 6 squared is 36 pi centimeters squared. In this case, we just brought pi down. We didn't solve using pi. All right, next slide. Make sure you have this written down. Okay, and here is the area of my square and my circle. The square is 144 centimeters squared. Our circle is 36 pi centimeters squared. Brainstorm some methods for finding half the area of the square and half the area of the circle. So, if we're going to look for half the area of the square and half the area of the circle, one way we can do this is by folding in half and counting the grid squares. Or we can cut each shape in half and count the squares by doing that, all right? So you could have just folded them in half or cut them in half and counted the grid squares. But in this case, we actually solved it, so we're golden. Let's keep going. All right, now find the area of half of a square and half of a circle. Okay, now, like we said, the area of the formula for area of half a square is s squared, and then once you find that, you just simply divide by 2 because you're looking for half. Same thing for the circle. Same formula. Area equals pi r squared. That should have been squared. My apologies. Pi r squared, and then once you're done, you're dividing by 2. Formula for area of a quarter of a circle. Same thing. Area equals pi r squared. Once again, this is not a 2. This should have been squared. Divided by 4 because of quarter of a circle. All right, let's keep going. Now we're going to practice some of these. I'm going to demonstrate a few problems on the board. Let's keep going. Now, before we start, I'm just going to go over the fact that students should recognize that composition area problems involve the decomposition of the shapes that make up the entire region. It is also very important for students to understand that there are several perspectives in decomposing each shape and that there is not just one correct method. Now, what this basically means is, at some point you will be asked to find the area of a figure that looks like this. Now, in order to do this, don't drive yourself crazy, because just by looking at it, you're like, oh my God, what's the formula for this? Don't drive yourself crazy. If the figure doesn't actually have a formula, all you have to do is break down into separate shapes. So although this is supposed to be together, what you can do is you can find the area of this, which looks like a square. Then you find the area of this, which looks like a rectangle. Then you take them both, add them together, and that'll give you the area of the whole figure. All right? And like I said, we're going to practice some of those later on. All right. Marjorie is designing a new set of placemats for her dining room table. She sketched a drawing of a placemat on graph paper. The diagram represents the area of the placemat consisting of a rectangle and 2 semicircles at the end. Each square on the grid measures inches in length. All right, so real quick, just to explain what this says. We're dealing with a woman named Marjorie, of course, who is designing a new set of placemats for her dining room table. Now, if you don't know what a placemat is, I'll explain real quick, just so you can have a better understanding. Now, I know most households, all households should have this. If you look in your kitchen on the dining room table, what you use to put your plate on the table so that your plate doesn't actually touch the table, you put a placemat underneath your plate. That is what a placemat is. All right. So the diagram represents, okay, so this right here is a diagram of the placemat right here at the bottom, the diagram of the placemat, okay, consisting of a rectangle. So if you look at the middle where this orange box is right here, this is a rectangle. And then when you look, and then it has two semicircles at either end. Each square on the grid measures oh my God, this should have said 4 inches. My apologies. This should have said 4 inches. So what I'm going to do is now I am going to pause this video. All right, so here's some formulas, a few extra. Okay. All right, now when finding the area of half of the when finding the area of half of the square and half of the circle, you're going to need some of these formulas. So it's the same thing as if you were looking for, half of the square. Only difference is once you find it, you're dividing it by 2. Same thing with the circle. Same formula, then you divide it by 2, and then when you're doing quarter of a circle, you're dividing by 4 because you're breaking it down into quarters. All right. All right, now I'm going to demonstrate a few problems on the board. Before I start, students should recognize that decomposition area problems involve the Okay, all right. Now, before we get started, students should recognize that composition area problems involve the decomposition of the shapes that make up the entire region. It is also very important for students to understand that there are several perspectives in decomposing each shape and that there is not just one correct method. All right, let me get my pointer and let's keep going. Okay, Marjorie is designing a new set of placemats for her dining room table. Now, if you don't know what a placemat is, you might have them in your kitchen on your dining room table. It's what you set your plate on so that your plate doesn't actually touch the kitchen table. All right. She sketched a drawing of the placemat on graph paper. The diagram below represents the area of placemat consisting of the place. Okay, let's start over. Take 2. Action. All right, now Marjorie is designing a new set of placemats for her dining room table. Now, real quick, if you don't know what a placemat is, every dining room. Okay, let's start over. Take 3. Marjorie is designing a new set of placemats for her dining room table. Now, to those who don't know what a placemat is, you might have them in your dining room. On the table is what we usually put our plates on so that our plates don't actually touch the table, so that, usually kids make a mess. So, you put a placemat on there so that when you're eating, you don't dirty the table. She sketched a drawing of the placemats on graph paper. The diagram represents the area of the placemats consisting of a rectangle and 2 semicircles at either end. Each square on the grid measures 4 inches in length. So real quick, here is our rectangle right here. This is the diagram of the placemat, all right? So the middle part is our rectangle, and at each end is a semicircle, all right? We are going to now find the area of the entire placemat, and we're going to explain our thinking regarding the solution to this problem, all right? So pause this video, take a second, and see if you can solve this. All right. Here we go. Now, here's my placemat. Now, please don't laugh at my drawing. This is a placemat, okay? This is the middle part, the rectangle that we were just talking about, okay? Now, a key piece of information is that each of these grids right here, so we have 3 of them in here, are 4 inches, okay? And if you notice that I already have my numbers in here, I know that this side is 8, this side is 8, this side is 12, this side is 12. Now, if we were in class, I would then ask you guys, where do you think I got these numbers from? Okay, and you would raise your hand and you would have to tell me now that if each of these are 4 inches long, 4 inches, 4 inches, 4 inches, 4 plus 4 is 8, plus another 4 is 12. So that's why I got 12 here. And if this is 12, then that is 12. All right, we're going to do the same thing for these sides now. This is 4, this is 4, 4 plus 4 is 8. If this side is 8, this side is also 8. All right, then we're going to quickly go and I'm going to show you that this is the rectangular region of the placemat. The rectangular region of the placemat is right here. Okay, so our formula for area of a rectangle, the formula for area of a rectangle, please write this down, is A equals length times width. A equals length times width, all right? So now our second line is where we substitute. A equals 12, 12 is our length, times 8, 8 is our width. 12 times 8 is 96. All right, make sure you are writing this down. Now, at each end, we have a semicircle. We have one semicircle here and one semicircle here. Now, there's two ways you can do this. Now, the harder way would be doing two separate semicircles, but that'll just be more work. Or you could take the two semicircles and solve it as one whole circle. Because if we took this semicircle and we took this one, and we took this one and we pushed them together, we would now have a circle. Okay, so we are going to call these two sides the circular region of the placemat. Okay, and now in order to do that, we now have to know what the formula for area of a circle is. The formula for area of a circle. Okay, now once again, if we're in class, I would be asking this as a question to see who would remember. So if you remembered, that's a plus. If you don't, that's fine. We're going over it. Just please write them down in your notes. A equals pi r squared. I'll say it again. A equals pi r squared. When we go to the next line, A equals pi, then we substitute our 4 in. Now, why did I substitute 4? Okay, let's go back up here. R, first of all, R is radius. So we have to know what the radius is for this circular region. Okay, so we have an 8. If we have an 8 going across here, what do you remember about radius? Okay, I will tell you. The radius, remember, the radius is half of the diameter. So if the diameter is 8, then our radius would be 4. All right? 4 squared is 16. Now we're going to bring our pi down as 3.14. 3.14 times 16 is 50.24 inches squared. Okay? And now we're going to take our rectangular region and our circular region, and we're going to add them together. 96 plus 50.24 equals 146.24 inches squared. All right? Please make sure you pause this video, write down what I have. And if you have any questions, I will answer them at a later time. Let's keep on going. Now, if Marjorie wants to make 6 placemats, so we already know in the previous slide right here that this whole placemat is 146.24, and I circled it at the bottom, 146.24 inches squared, okay? So if one of them equals that, how about 6 placemats? So if Marjorie wants to make 6 placemats, how many square inches of fabric will she need, assuming there is no waste? So we want to know how much fabric will she need to make the placemats. All right, and here we have it. So as you can see, I took the amount of inches it was for 1, which was 146.24, and I multiply that. I basically multiplied that by 6, and this is what I got. All right. Okay, the circumference of a circle is 24 pi centimeters. What is the exact area of the circle? Okay. Now, what's going on here is it's giving us the circumference of the circle. And with that information, we need some more information to find out what the area is. So we have the circumference, but first, we need to find what the radius is. So we know that the circumference, which is the total around the circle, is 24 pi centimeters. Now we have to know what the radius is. This is our radius. We have to find out what our radius is. And then once we find the radius, we can then find out what the area is. All right? So here at the very top, as you can see, I already wrote down the formula for you. Okay? C equals 2 pi r. Okay? Now we know we can replace C. Now we're going to substitute. Now we know by looking back at this, it said circumference of a circle is 24 pi centimeters. Okay. So C, we replaced that with 24 pi, and then we brought everything else down. Now we're looking for R. So we're looking to isolate R. We don't want to isolate the variable because that's what we're looking for. Right? We want to get R by itself. So by doing that, we're going to divide by 2 pi, and then we're going to do the same thing over here. These cancel out, the pi's cancel out. So now we're left with, we have R on this side by itself, the R comes down, then we have 24 divided by 2, which is 12. So now we have a radius of 12. We have a circle with the circumference of 24 pi, and we have a radius of 12. All right. Now we can find out what our area is. Let's keep going. Boom. Voila. First, you find the radius, which is at the top. Okay, which we just did. And then you can now find out what the area is. Now, the formula for area, can anybody tell me? Anybody in the back? All right, I'll tell you. Area equals pi r squared. Area equals pi r squared. Okay? Area of a circle, equals pi r squared. Okay? Now, let's substitute. Area equals pi. Our radius is 12 squared. Okay? Now, 12 squared is 144. We're going to keep the pi down here. So the area of this circle is 144 pi centimeters squared. All right? Please pause this video and copy down the notes. If there's something you don't understand, put a question mark next to it, and in the next help session that we have live, you can either email me or ask your questions then. Let's keep going. All right, find the area of a circle with a diameter of 42 centimeters. Find the area of a circle with a diameter of 42 centimeters. So we know that what we're looking for here is where it says find the area of a circle. So we're looking for the area of a circle. Now, what it tells us, it gives us the fact that the diameter, which means where our circle cuts in half, it is 42 centimeters. Now, we're going to use pi as an approximate for 22 over 7. Now, I will explain what this means shortly. Let's get into it. Okay. Now, the formula for area of a circle is, can anybody tell me? The formula for area of a circle is A equals pi r squared. You make sure you are writing this down. Now let's substitute. A equals pi times 21. Where did we get 21 from? Can somebody raise their hand and tell me where we got 21 from? Anybody? Anybody? All right, I'll tell you. So remember, radius is half of diameter, right? So if we have a diameter of 42, and if radius is half the diameter, what would we put for the radius? We would take 42 and we would divide it by 2 or cut it in half, which would give us 21. Okay? Now 21 squared is 441. Okay? Now, whenever you see this part right here where it says use pi, you use this squiggly equal sign. It's like an equal sign, but it's squiggly. It's an approximate. Okay? So if we want to get, sorry. Now, this is how it wants us to solve. Whenever it wants us to solve it as a fraction, when it wants us to use pi as a fraction, it'll tell you to use this approximate. So in this case, we're going to substitute pi as 22 over 7. Okay? And we have to multiply by 441. So I put that over 1. So it's like we're multiplying fractions now. Now, there's some things that we can cancel out. 7 goes into 441. How many times? 63 times. So those cancel out. And we bring the 63 in. Now, our numerator consists of 22 times 63. Our denominator still has our 1. 22 times 63 equals 1,386. Divide that by 1, and we are left with our final answer, which is 1,386. Now remember, please copy this down. Any questions, place a question mark around it, and I will answer your questions at a later time. All right, the circumference of a circle is 9 pi centimeters. There's 3 things that we want now. So it tells us that the circumference of the circle is 9 pi centimeters. Sorry, 9 pi centimeters is the circumference of this circle that we're going to figure out soon. Now, there's 3 things that it's looking for. From the circumference that is given to us, we now have to determine what the diameter is. 2, we have to determine what the radius is. And last but not least, then we can determine what the area is. All right? So we have to find the diameter, we have to solve for the radius, and then we have to solve for the area. Okay? Okay, here we are. Now, remember, if you look at the top here, it told us that the circumference of a circle is 9 pi. So here is the formula. First, what's the first thing we're looking for is diameter, then radius, then area. So diameter, then radius, then area. Okay, cool. So here's diameter. Here's the formula for diameter. D equals C over pi. Okay, that is the formula. Okay. Now, circumference is given to us. It was 9 pi. So C, where it was C, we're going to replace C with 9 pi. Why? Because it tells us right here that circumference of a circle equals 9 pi. We're going to divide 9 pi by pi. Pi and pi cancels out. D equals 9. All right, so our diameter is 9. So now that we know what our diameter is, we can now figure out our radius, okay? And we all know that the diameter, or the radius, I should say, is half. The radius, remember, is half of the diameter. Repeat it with me. The radius is half of the diameter. Let's repeat it together one more time. The radius is half of the diameter. So with that being said, we're going to replace that D with a 9 because we know the diameter is 9. So 9 divided by 2 is 4.5, or you could have left it at 9 divided by 2. Okay, so whichever one of these answers, either one would be fine. Now let's find, now that we have the diameter, we know what our radius is. Now we can find out what our formula is. Now we can find out what our area is. Now the area for formula for area of a circle, the formula for area of a circle is A equals pi r squared. Formula for area of a circle is A equals pi r squared. All right. Now let's go down here and substitute. We have, for our radius, we had 9 over 2. 9 over 2 squared gives us 81 over 4. 81 over 4 pi centimeters squared is our final answer. Let's keep going. Find the area in the rectangle between the two quarter circles if AF equals 7 feet, FB equals 9 feet, and HD equals 7 feet. Okay, now we're going to use 22 over 7 as pi. Each quarter circle in the top left and lower left corners have the same radius. Okay, now remember, AF, which is right here, AF is 7 feet. FB, which is from here to here, is 9 feet. So we know that 7, and we know this is 9. That would be a total of 16. So we know that this whole side right here is 16. Then it also says that HD, which is from here to here, is 7. From here to here is 7. So if here to here is 7, then this would also be 7, okay? And then this would also be 7, and this would also be 7, all right? So we know that this is 16, and if this is 7 and this is 7, then this side is 14. So we have 14 times 16, all right? All right, here is the work that I did so I can show you how this is done, okay? At some point, please, like I said, pause this video and please write down everything that I have here. Now, let me explain. Remember what we said. This is 7, this is 7, so the width is 14, and the length, 7 plus 9, which is the length, is 16. So 16 times 14 is 224 feet squared. Then let's come to this side over here. Let's come to this side over here. Now we have 2 quarter circles. We have one over here, and we have one over here. Now if we take these 2 quarter circles and we put them together, that gives us a half circle. So our formula to finding a half, and you can do this 2 different ways. You could either do it regularly by finding a regular circle, and then at the end you divide it by 2, so cut it in half, or you could just start off by multiplying by a half, okay? Now, we have area of a half circle. The formula for area of a half circle is 1 over 2 times pi times r squared, okay? So let's do our little substitution here. The half stays. 22 over 7 is what represents the approximate for pi times 7 squared. Now, let's start solving this. So we had half times 22 over 7 times 49 over 1. Now, being that we're multiplying fractions, we want to keep everything as a fraction, so we put this 49, which was originally 7 squared, and we know that 7 squared equals 49. We put that over 1, and then we started canceling out. So our 1's can cancel out. Boom, boom, knocked out the 1's. 2 goes into 22 11 times. That's why I crossed out the 22 and put 11. 7 goes into 49 7 times. That's why I crossed out the 49 and put a 7. Okay? Now we are left with 11 times 7. So I brought that down over here, 11 times 7. And that final answer would be area of the half circle would be 77 feet squared. 77 feet squared. All right? And then what we'll do is we want to find out what the area of this region of our figure is between the two semicircles. So we just want in here without the semicircles. So we know that the whole thing is 224. We know that the half circle is 77. So we're just going to subtract the half circle, because we don't need that part, from the whole, and we have 147 feet squared. All right. Now, we have reached the end of lesson 18. Now, here's some key points. The area of a semicircular region is half of the area of a circle with the same radius. Also, the area of a quarter of a circular region is 1/4 of the area of a circle with the same radius. Take two. All right, now we have reached the end of lesson 18, and here are some key points. Please read along with me. The area of a semicircular region is half of the area of a circle with the same radius. The area of a quarter of a circular region is 1/4 of the area of a circle with the same radius. If a problem asks you to use 22/7 for pi, look for ways to use fraction arithmetic to simplify your computations in the problem. Problems that involve the composition of several shapes may be decomposed in more than one way. All right, now we have reached the end of this lesson. And here are some key points. All right. The area of a All right, so we've reached the end of this lesson. And here are some key points. All right. Just follow along, and then at the end, make sure you write all of this down. The area of a semicircular region is 1/2. Take 4. All right, so we have reached the end of this lesson. And here are some key points. The area of a semicircular region is half of the area of a circle with the same radius. The area of a quarter of a circular region is 1/4 of the area of a circle with the same radius. If a problem asks you to use 22/7 for pi, look for ways to use fraction arithmetic to simplify your computations in the problem. Problems that involve the composition of several shapes may be decomposed in more than one way. All right? Now, please pause this part of the video and write all of this down. Okay? Now, I look forward to seeing all of you guys soon. Until then, we will continue on with the lessons just like this. I will also upload an assignment that will have all this information that we just went over, all the work that we just did. You are going to use our notes from today to answer the questions from the assignment. I won't make it long. I'll probably only put 3 problems on there. As long as you took good notes, as long as you were paying attention, you will do fine. All right? See you soon, and I hope to hear from all you guys. All right? Thank you, and have a blessed evening.